easy. So 4151, 4142 and 513 homework due tonight. Anyone have any questions on 4142 and 51? Derek, make sure that, Derek, for your problem with all your homework is, this is for everyone. So please pay attention here. This is something I want to tell everyone here because a lot of, I got some students who are doing it already. Derek is one of them, I'm gonna point out. I'm gonna tell you guys right away right now is, do not do this in your test. I will take points off. If you find yourself a vertical asymptote, and let's say the vertical asymptote is 3, if you put 3 down, you won't get full point. You will get wrong in your online homework. The reason why it's wrong, anyone know why? If you put 3 down, it's wrong. Anyone know why? Yes, you need x equals 2. That's why, Derek, why you got it right. You just forget to put x equals 2. For all the horizontal asymptote, your answer, let's say, is 1/2, which is also right, but they will mark you wrong. Oh yeah, they will know which one is y and x. All your vertical is x. All your horizontal or your oblique asymptote should be have y equals 2. Yes, you need to do this. This is something that if you don't give me x equals to y equals to on your asymptotes, you will get wrong. Not wrong, I will take points off in your test. And you will get wrong in your online homework. So that's the reason why a lot of you get the answer correct. Unfortunately, you get it wrong because you forget to put x equals to or y equals to. Yes, vertical asymptote is always x equals to because it is vertical. So you go like this, it's an x equals to. And horizontal is y equals to because it goes horizontal. Your oblique asymptote is also y equals to mx plus b, like 3x plus 2, something like that, because that is going to be a oblique asymptote. So that's the reason why that those students who did not give me x or equals to or y equals to in your homework and your test, I will take points off. You guys all clear with me now? This is really, I want you guys to know all this with you guys. So you need to know this. And that's why I got students really asking me why this is wrong. This is the reason why you get it wrong, because you forget that. Okay. We're going to continue with 4.1 question number 21. So 4.1 question 21. This is 4.1 question 21. They're asking us C is in dollars. This is the equation is. This question for part B. B is the one that a lot of students needs kind of. They want you to do 25% of it. So when you put 25% onto this, do you look at this question carefully that your P in this case is 20, your P in this case in percent. So when you guys do this, you do not need to change it to decimal. You just plug this into here. So C in this case will be 2,500 times 25. No, don't change to 0.25. 100 minus 25. And then you use your calculator and you get your answer in this case. So this is how you do for question B, 25, 55, 85%, is you change this to 25 and 85 and 55, what they call you. Do not change this to 0.25 and plug it in there, okay? That will be wrong. You guys clear with this 4.1 question 21? 21, question 21. Okay, so this is the one that I see a lot. Some students ask me is do not change this to percent, to decimal, just use as percent 25. 4.2 question 6. This is question 6 in this case. All right, I want you guys to find what is your domain for question 6. Anyone know what's the domain for question 6? A, B, C, D, or E? Question 6. What's the domain? All real numbers except x equals to 6. Yes, because you take your denominator and you make it equal to 0, and that's where you get your 6. So yes, B is the correct answer in this case. Next, how you find your x-intercept. Don't forget it is going to be in a coordinates form. So x-intercept is you take your numerator. So in order for us to find the x-intercept, you take your numerator equals to 0 and solve for x. But our numerator in this case is 1. Unfortunately, there is no x in this case, so you cannot solve for x here. So in this case, it's DNE. So your x-intercept in this case does not exist, DNE. For your y-intercept, you need to make all your x to become 0. So you set the x become 0, y, which is f of x, equals to 1 over 0 minus 6, which gives us negative 1/6. So we have a y-intercept. This is 0, negative 1 over 6. Now you find the asymptotes. So how do you find your vertical asymptote? Does anyone remember how you find your vertical asymptote? Anyone remember? How you find your vertical asymptote? Anyone? Vertical asymptote? Anyone? Naira, Jackson, Lindsay, how you find your vertical asymptote? Anyone? You take what equals to 0 for vertical asymptote. You guys here? You guys with me? Yes, you take your denominator equals to 0. So in this case, you put x minus 6 equals to 0. Yep. So in this case, x is what? Equals to 6. So who is this Abimbola? Abimbola, who are you? Can you change your name? I don't know who Abimbola is. I don't know who that's. And then next, to find your horizontal asymptote. So in order for us to find the horizontal asymptote, you look at your power. So the top one here is power 0 because there's no x. And the bottom one is a power 1. So 0 in this case is less than 1. So what you get when you have this case when 0, the top power is less than the bottom power. What kind of horizontal asymptote do we have? This is for question 6. Anyone? What is your horizontal in this case? Yes, it's y equals to 0. You are correct. Once you get this top one is less than the bottom one is y equals 0. So class, if you just give me 6 and 0 here, you will get it wrong. And the reason why you get it wrong is because you didn't put x equals to 6 and y equals to 0. That's the reason why they will mark you wrong in this case. So what is your graph looks like? Because x equals to 6 is your vertical asymptote. So it looks something like either A or D, because this one is at -6. So we know it's wrong. This 2 is wrong. So this is 1 over. So we did not flip it on the y-axis. So your answer in this case will be A in this case. So this is how we do your answer here, your questions here. Again, class, make sure you put x equals 2 and y equals 2 for your vertical and your horizontal asymptotes. Okay, and if there are no asymptotes, you put DNE. Let's say that let's say that you don't have a horizontal asymptote, you only get vertical asymptote, then you just put x equals to 6 here. Okay, so let's say that your horizontal asymptote doesn't have 1. your answer is just x equals to 6. Okay, don't put x equals to 6 and then DNE. They will mark you wrong. Okay, DNE stands for no asymptote, means you don't have a vertical and you don't have a horizontal. Then you give me the DNE. So DNE only exists when both of these does not exist. Okay, so make sure you guys know how to put your answer here. So this is your 4.1 to 4.2 homework questions. Anyone have any questions for me regarding with your homework? 414251, which is due tonight. Anyone? Anyone have any questions before I continue with 5.2? All right. So if you do, you either ask me after class or ask me. I will do it for you. So 5.2 is doing, so 5.1 we're doing exponential. So 5.2 we are doing logarithm. So as you guys remember back in chapter 2 when we talk about inverse function, inverse function has to have a 1-to-1. Okay, so when you have a 1-to-1, it will have an inverse function, and in order for it to be 1-to-1, it has to pass the horizontal line test. That means that when you draw me the horizontal line, you only cross at one point. Okay, then we have 1-to-1 in this case. If you look at your 5.1 that we did last time, this is the exponents graph that we have here. These are the two exponents graph that we have here. And when you draw a horizontal line, it will cross this graph at one time. Okay, it will cross the graph at one time. No matter which graph you give it to me, they will cross this at one time. Even down over here, it will cross this at one point. Because when you go down, when you draw a line, it's going to be exactly one point. Same thing with the E graph, the natural base. If you draw the horizontal line, it crosses at one point. So you can tell that all these exponents graph that you did in 5.1 passes the horizontal line test. So it has an inverse function. And what is the inverse function for exponents? So for all the exponents, the inverse function is called the logarithmic functions with base A. So in this case, that AX is the inverse function is log AX. Same thing happens is log AX is the same thing as AX. So this is what we call as, sometimes I call that as move the base. Okay, so sometimes I call this is moving the base. So what I mean by moving the base is I just move the base around to change from log to exponents or exponents to log. What do I mean by here is, for example, is this one. Y equals to log AX is the same thing as X equals to AY. What do I do here is I move the base. I move it base up there. So that's why the log disappeared. So you get X equals to A to the power of Y. Or I can move the base A down here. So you become log AX, then the Y goes down. So for example, is 2 log 3y. I can move this 3 over to the other side. So the log disappeared. It becomes 9 is equals to 3 squared. So this is what we call as move the base. And this is how we change from log to exponents or exponents to log. Remember last time when you guys do changing the inverse function, what you do first, you change the x and y around, right? And then you solve for y and then change the inverse. You do not need to do that for this case. Okay, for log and exponents, you just do what I just teach you just now. Just change your base in this case. Now, if you look at your calculator, all your calculator only have the symbol log on it. So if you look at your calculator, they all have log. There's no base on it, log. So this is what we call as log without anything. So in your calculator, if you see log, it means it's common log, means the base is 10. So that means I want to point out to you that your calculator only have base 10 log. They don't have base 3, like log 3 or log 2. They don't have it. They only have log, or in the same thing as log 10, which is base 10. We call it as common log. So I just want to point out to you that, well, how do you find log 2 or log 3, something like that? you have to use the change of base formula, which you will learn in the next section. Properties, there are a few properties you need to know. Log A1 is equals to 0. So A0 equals to 1. So make sure that if your, this is what we call as argument. If your argument is 1, you get 0. Log AA, if your base and your argument is exactly the same, you get 1. Log AAX, so if you have the base and the argument the same with the power x, you will get x. Same thing with log A to the power of log AY. So the base is the same, you cancel it out, you get x. And then this is what we call one-to-one. As long as your log has the same base, your argument can be equals together. And this is the 5 very important one. Log A, any negative number is undefined. Okay, so log any base with a negative number is undefined. And one thing also I want to point out here is log A0 is also undefined. Okay, so that means that if your argument is 0 or your argument is negative numbers, you will get undefined. If you get 1 is 0, any numbers is 1. So this is what we call as the properties of log, which is very important. So make sure you guys know what the properties here, and we got a few more properties of log here. Graph, how do we graph this log A function? So we start out with A, in this case it has to be greater than 1. I start with 2. So if I put log 2x, how do I do this is based on your coordinates. So so what I do is I cannot use 0 or cannot use negative number. The reason why we cannot use 0 or negative numbers in this case is because negative number or 0 is make it undefined. So I want to tell you that when you do log 2x, log 3x, log 4x, you will never cross on this negative side. And you never touches 0. So it can be any other numbers beside those. So how do we do, we start with doing is you plug 1 in there. So when you plug x to become 1, log 2 to the 1 is going to be 0. So when you look at this, log 2, 1, the first property, you will get 0. So that means that all your log base, whatever 2 or 3 or 4, you will have a 1, 0 coordinate. So this is a must to have. This coordinate point is a must. So if you remember last time in exponents, the coordinate point that you must have is 0, 1, this point, right? And if you remember the inverse function, if 1, 0, you flip it, becomes 0, 1. So that's the reason why that you get 0, 1 in this case. Okay. How do we do the next one is we use the base. So we want them to be the same base. Now, since your base is 2, so when x is 2, your y in this case will be log 2, 2. And log 2, 2 in this case is 1. What do you mean by log 2, 2 is 1? Is because your base, number 2 here, if your base and your argument is the same, you get 1. So that's why you get, when x is 2, you get 1 in this case. Okay, so you get 1 here. And then next, we will use the power. So what you do with this 2, you begin to power it. So you begin to square it. So 2 squared is 4. So you get log 2, 4. And 4 in this case is 2 to the power of 2. And if you look at the third properties of log, if you have your base and your argument is the same, they will cancel it, you will get 2. So the point that we have here is 4 and 2. So what happens in this case, class, is I just want to point out to you that when you draw a log function is actually like power, but you do it opposite. So like first thing is we do power 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4, you get 2. So the next one is 3. So what is this number? Anyone know what this number will be if this is at 3? Anyone know what number is this? Someone say something. Not 9. Good try. Not 9 because it's 2. Not 9. Good try, but not 9. So because this is log 2, this is going to be 8. And why I say this is 8? Because this is 2 to the power of 3. So this 3 came from the power here. So that's why we got 8. So if you look at all this graph will give us 2 to the power of 0. And then 2 to the power of 1. And then you got 2 to the power of 2. And then you got 2 to the power of 3, which is 3. The next one will be 2 to the power of 4, which is 16. So at 16, you will get 4 in here, like the 4 inside here. So at 16, you will get 4. And then this one, you get 1/2, 1/4, 1/8, 1/16. So your answer here is getting closer and closer to 0. So you won't touch 0 at all. So this is what happens when you have log 2x. So what happens when you have a log 3x? So what is your graph will looks like when you have log 3x? So you still have the 1, 0. But now when x is 1, you take 3 to the power of 1. So that is 3. And then if you want 2, you power it to 2. So 3 squared is 9. And then if you want to get 3, you power it to the 3. 3 cubed in this case is 27. Okay. And if you want to go less, you can do like smaller number. In this case, we do like we can do like, let's say let's take -1. So when you do -1 here, is 1/3. And then when you do -2, if you put -2 here, this is 1/9, which is even closer. So you find out that this graph is log 3x. Will this cross at your y-axis? No. Will it touch your y-axis? No. That means that your y-axis here is your horizontal asymptote. Okay. And if you compare this log 3x with log 2x, you still have 1, but you got 2 in here, 2, 1. And then you got 4, you get 2. And then you got 8, you get 3. So your log 2x is actually a little bit higher. This is log 2x. So what can you tell me if I increase your base from log 2 to log 3 to log 5x, log 8x, and so on, so on? What happens to this graph? What happens if I want you to draw a graph for log 5x? What happens? Anyone remember? This is your x-axis. You still have a 0, 1, 0 here. Every time, no matter log whatever you have, you still have a 1, 0. This is an important point because when you guys do transformation, this is the point that you move transformation. So what happens when you have log 5x? This graph will get closer and closer towards the x-axis. So for log 5x, your graph will look something like this. So log 2, log 3, log 5, and then log 6 is even closer, but it will never cross the x-axis as long, that means it's getting closer and closer to it. So this is how we figure out your log power, okay? What happens if your power is So let's talk about the domain. So the domain for this is all from 0 to infinity because it doesn't go to negative, cannot be including 0. Your range is all real numbers. It has an x-intercept of 1, 0. And this graph is always increasing from 0 to infinity. And it has a vertical asymptote at x equals to 0. And if you compare the log 2x with 2x that you guys did in 5.1, you find out that the domain here is all real numbers. The range here is from 0 to infinity. And you notice that the domain and range for these two is been flipped around because that is the meaning of the inverse function that you guys learned. Okay, it doesn't have a x-intercept. It has a y-intercept. It is going to be at 0, 1, which is also one of the case of your inverse function. AB become BA, you switch them around. This function is also increasing from all real numbers. Okay, it's increasing in all real numbers, and it does not have a vertical, it has a horizontal asymptote at y equals to 0. So what happens here is that your log function has a vertical asymptote of x equals to 0, but your exponents has horizontal asymptote of y equals to 0. So that's the meaning of those. So next we talk about e. So in exponents we have the e. We call that as the natural exponents. So and ex is also past the horizontal line test, so it has a log function. So that log function is become ln. Okay, so when you see ln is called natural log, it's the same thing as log base e. So you see a lot of ln x. So ln x, if you want to graph this, is very similar to this. Okay. Because we know E in this case is 2.7 something. So if you want to draw a graph of log EX, where E in this case is 2.7 something, then it will be somewhere near the black line. So this is the lnx line. The reason why is because this is log 2, this is log 2.7, which is E. And this is log 3, and then the other one is log 4, and then log 5, and then log 6. So you find out that in order for you to draw the lnx graph, your lnx graph should be in between log 2 and log 3. To be more precise, if you have an ln graph, you always have the 0, 1 here. This is your E. You get 1. This will be your E square. You will get 2. So ln graph is where your you got E3, E power 3, this is 3. So this is the meaning of the ln graph in this case. Okay. So same properties log and ln. ln1 is 0, ln e is 1, ln ex is x, and for one-to-one property, ln x is the same thing as ln y. So these are the same one-to-one property in this case. So we'll look at some homework questions here for this part. So for 5.2, in order for you to do 5.2, let's see. The first one is asking us to write this in a log to the exponents form. For example, log 525, you just move the base. We call it move the base. So in this case, you just move the base over here. So in this case, your 4 would move over. So you get 16 is equals to 4 to the power of 2. That's it. You do not know solving. You just move the base here. Okay. Just move the 4 over there. And then you got 16 equals to 4 over 2. I want you guys to try to do question number 8. They are the same. Do number 8. 7, 8 is the same. And private message me how you change this to become exponents, like what I just did here. I moved the 4 over and I got 16 equals to 4 squared. I want you to do the same thing for question 8. We call it move the base. It has to be equal. And Jackson does. That one is equals to what? Partially right. You have to put equal like here. This is equals to 16. So what is that equal to? And where I get the 16 from is the argument from the log. So this one should be something. Jackson, those are close by. Yes, that is correct, Jackson. That is correct. Yep, that is correct, Josh. Yep. Anyone? This is not tough. Moving this base is easy. No math required. Just move the base over. Yep, Kayana where is correct. So you just move the 729 over. Lindsay is correct. So you will get 9 is equals to 729 to the power of 1/3. Yep, this is how you write your answer. This is how we do this. This is easy. This is not tough. Now we do the opposite now. I give you the exponents, you give me the log. So what you move the base. So this 6 is your base. I move it down there. So I will become 3, because the 3 is a power, equals to log base 6. Where's my log friend? So you have to figure out, there you go. I think it's under one of these. Where's my log friend? Is it over here? No, there you go. Log 6, 216. So this is how you find the log is right over here. The 6, because you move the base from here, become there, and then 216 is here, and then close your parentheses. Don't forget to close your parentheses. And this is how you do this question. You guys doing all right here? So it's pretty much straightforward type. We're gonna do number 11. So go ahead and do number 11 here. Maybe I just skip it because this is easy. I'll let you guys. We'll do something else besides, because this is a bit easy to do. So so 12. We do 12. 12 is a bit tough. So this moving base is easy. You do not need to solve it. So it's pretty much. So for question 12, you have to evaluate log 6x, 16x, and x in this case is 4. So if you give me log 16/4 in your answer, you get it wrong. So what you need to do here is you want to change this 4 to become 16. So does anyone here know how to change 4 to become 16 or 16 become 4? Because we want them to become the same base here. Anyone? Yes, 4 squared will give us 16. But I want 16 now, not the, so I want the other way around. So in this case, this will be 1/2. Okay, so square root of 16 will give us 4. And because the base is the same, this is 1/2. So this is one way to do it, which is difficult. Another way, so one way to do this, which is hard. Another way, which is an easy way, I'm going to show it to you, is log 16x 4. And you just make this equals to x. Okay. And what you need to do here is you move the, like we just did just now, we move the 16 over. So 4 in this case is 16 to the power of x. And as Elijah told me, 16 is 4 squared, which is correct. So 4 squared equals x. Now, since this is having the same base and this one is a power 1, so you can make the power the same. So the power here is 1 and the power here is 2x, because power to the power you multiply. So x in this case is 1/2. So you still get the same answer as that. Okay, so your answer for question 12 is 1/2. Okay. For question 13, log 6(1), because our x in this case is 1. Does anyone know what is log 6(1) is? This is based on your formula that we have. Remember, log any base to the 1, you get what? Log base anything to the 1, you get 0. Yes, so in this case, for this question, you will get 0. Yep, that is the answer for him. This is 0. So don't forget that if you see 1 here, your answer is 1. I don't care. 0. I don't care what is your base is. Then we put 1000 for 14. Log 1000. My x is 1000. And now, if you guys doesn't know this, does anyone know what base is this for question 14? There's no number underneath it, right? What base is that? Yes, this is base 10. You are correct. So if you want, you can write this equals to x like what we did over on this side. And then I just move the 10 over here. So we got 1000 equals to 10 to the power of x. Now my question is, can you write? Yes. So 1000 is 10 to the power of 3 because 10 times 10 times 10 is 1000. So x in this case will be 3. So your answer in this case will be 3 here. So majority of this question is you don't use a calculator, and then you can actually figure out using the formulas that is shown over here, these formulas. Okay. So use this formula to do this kind of questions, then you will get how to do that. Okay. Next question 16, you have to use a formula. Use a calculator to plug this in there. So how do we use a calculator in this case is you have to plug 1 over 650 over there. So you have the one, so you do, for this calculator, you do 1 over 650 first because it's a weird calculator one. And then you do the log. So this give me negative 2.813. Okay, so for this case, you do the 1 over. So if you have your normal calculator like this one, you just type log 1 over 650. Calculator, you just type log then 1 over 650. Yes. What's that? Diana? Someone say something. So, and then you will still get the same answer, negative 2.8 something. Okay, so make sure you guys know what to do on this question. So for calculator part, you just use your calculator. And anyone know how to do number 17, log 44? What's log 44 is? Log 44 give you, anyone? Same base, same argument? Yes, 1. Thank you. Okay. Remember I told you what happens log 7.5 with 1. What happens if your argument is 1? What is number 18 is? Yep, 0. Now for question 19, since your base are the same, you see 5 and 5 is the same, you cancel them out. So if you cancel them out, what you left? And that's your answer. And so if you see 5 and 5, the base is the same, you can cancel them all out. So you left with the number 13. So that is your answer in this case. Okay. So if you get 5 log anything base, the same base, and your argument, that is your answer, 13 in this case. Okay. Now we use one-to-one property. This is also very easy. So one-to-one property says that as long as your base is the same, you can make your argument equal. Like number 20, the base is the same. So you can just make x minus 1 equals to 9. So x in this case is 10. Yep, very easy. Okay, this is what we call one-to-one property. 21, the base is the same, so you get x squared plus 2x equals to 24. Now this one is a little bit more difficult because it is a quadratic. You have to make this equals to 0 first. So I subtract 24 or move 24 to that side. And you have to factor this. Yes, this one requires factor. Can someone tell me what times what is 24? But when you add them, you get 2. What times what is 24? But when you add them, you get 2. What 2 numbers? Yep, positive 6 and negative 4. Yeah. So this will give me a negative 24 when you multiply. When you add, you get positive 2. So x in this case is negative 6, and x in this case is 4. So in this question 21, you got 2 answers in this case. Okay. You guys all right here? Next is question 22. Now, how do you sketch these two? It's very easy. If you do 6x, your answer in this case is going to be, so every time when you graph two, one is exponents and one is log. Exponents will look something like this. You cross at 1. And log will look something like this. And it will cross at 1 on the x. And then if you draw the line y equals to x, this red dotted line y equals to x, you find out that these two lines are kind of like they coincide. If you flip it, they reflect to each other. So in this case, we can tell that your answer here is A. This one, because usually you cross at 1 and 1 there. Okay, they will cross at 1 in each one. Okay, so the graph is a little bit tough until we go through some transformation. Yes, we're going to talk about transformation now. So this is something that you guys need to worry about. And please pay attention here. Very important. So we, let's say you got a transformation going up 3. For exponents, this is up 3. Okay. For log, this is up 3. Okay. If I want to put parentheses, the parenthesis is right here. Okay. If I want to go down, let's say 3, then I will do exponents minus 3. This is minus. For log, minus 3. This is up 3. This is down 3. If you want to go to the right 3, watch carefully, minus 3. So for exponents, if you want to do right 3, this is what your exponent looks like. Again, this 4 that you see here has nothing to do with your anything, with your transformation. It's only doing your basic graph. So all this 4 that you see here has nothing to do with your transformation. Okay. For log, it's inside, and there must be minus. So see the difference between up and down, left and right? And left 3 is a plus 3. And plus 3. You guys see the difference here? So can someone tell me on question 23 here, what transformation do we have here? Up, down, left, or right? Don't give me one. I want to know. Type down left 1, right 1, up, down. I don't know which one. Jackson is correct. Pasi is correct. Adam, right is correct. So this one you move right to the 1. So what happens to this graph is you have the log 3x first. And log 3x, you will intercept at 1. 3 will be at 1. Because that 3 is here, and 9 will be at 2. So this graph is log 3x. We call it your parent graph or your basic graph without transformation. Now what you need to do with this graph is you told me to move right 1, right? So this graph, which is at 1 here, will move to 2. This one used to be at 3, it will move at 4. This one used to be at 9, it will move at 10. Now your asymptote, your vertical asymptote used to be at 0. Now you have to move to 1. That means that it never crossed at 1 here. So your graph in this case will look something like this. So that means that now it's at 2. So can you tell me which one is the graph that shows that what I just graded, what I just drawn? Is that A? Is that B? Is that C? Or is that D? A, B, C, or D? Yep, that would be B because it crossed at 2. So the main part here is it crossed at 2. You see the graph crossed at 2? So you just need to figure out where is it cross for x is 2. The only part is B is the correct one in this case. That cross at 2. Okay. You say what? 1 unit to the right? So that means your answer is this one. The graph shifted 1 unit to the right. Log 8x. What is the domain of this? Anyone know what's the domain for this one? If you remember from here, if you have log, the domain is always what? 0 to infinity. If you haven't moved anything yet, we do left, right, up, down. Range is all real numbers. So can you tell me what is your domain of this function in interval notation? It's going to be the same as this. The domain is going to go from 0 to infinity. Yep, 0 to infinity will be the correct one answer here. Oops, sorry. I don't want to put that one up. So 0 to infinity. So 0 is not included. Don't put brackets here. And then where's my infinity symbol? So no brackets here. If you notice carefully, if you put bracket, they will mark you wrong. Okay, so 0 to infinity. Then all these parentheses. There you go. What is your x-intercept? So again, if you remember my notes here, the x-intercept is at where? 1, 0. So this is your answer here, 1, 0. What is your vertical asymptote? Again, this is the same thing. The vertical asymptote is x equals to 0. So make sure you put x equals to, oh, they got x already, so it's good. Let's just put 0 then, otherwise they will. How do you graph this? It will be intercept at 1, 0. And the next thing that you see here is because this is a log 8. Now remember last time when I do log 3, I put 3 here. So what happens when you have a log 8x? So you still have 1 here. Can someone tell me what is the next number on the x-axis after 1? For log 8x. Last time I say log 3x, I use 3, right? And 1. And then I do 9, because 3 squared is 9, is 2. So what is this going to be if I want you to do log 8x? 1, 0. What's the next number we have to use here? It's based on your base. So what we have here? Yep, 8 and 1. And if I want to go on to the next one, will be what? You square the 8. What is 8 squared? You square the 8, you become 64, and you will get 2. Yes, Harry, you're correct. So this is your graph. That means this graph is very, very close to your x-axis. So can you tell me which one gives you this graph? A, B, C, or D? A, B, C, or D? That'll be definite B, because you see 8 is 1. Okay, this 8 is not 1, it's a big number. So that's why your answer here is B in this case. Okay, so this is how we, I will recommend you guys to do this. I will continue with the transformation here. So the main part is all this transformation, and then I got 2 more left, which is the reflection. I'm not going to do stretching, and I will do a little bit. Yeah, I will show it to you the stretching and shrinking in this case too. So so this is your There you go. So this is left 3, and so the next one we're gonna do is your reflection. So in order for you to have a reflections on the x-axis, okay, you will have a negative in front. This is a reflection on the x-axis, or you got a negative in front of your log 4x. So when you see a negative in front of your log 4 or the 4x, is a reflection on the x-axis. And if you have a reflections on the y-axis, the negative is on top and the negative is inside. You guys see the difference between reflections on the x and the reflections on the y? So you can tell by looking at something like this. This one is definitely a reflection on what? Question 26, x or the y-axis. If I have a negative inside of x. So this is a reflections on the x or your y for question 26. Yep, this is a reflections on the y. So what you have last time is a log x, which is this is a log x. So what happens when you reflect this on the y-axis? What happens to your graph? It will go to the other side. So this blue line is the reflections on the y-axis. So which one you think your graph will look like? Is that A? Is that B? Is that C? Or is that D when you reflect this on the y-axis? A, B, C, D. A, B, C, or D. This is the reflection on the y-axis here. Which one? A, B, C, or D? Redraw the graph. This is the graph looks like when you reflect on the y-axis, right? This is the y-axis reflection. This is the original, you reflect this. So which one looks like? So it's gonna be C, yes. It's gonna be on this one. So make sure you guys try to do this on your own. The next one we're gonna talk about here is 5.3, but before I continue with 5.3, can you guys do the attendance here? Present, thank you. So 5.3 is what we talk about the properties of log. So there are 4 important properties of log here. The first property is called change of base. Change of base means that I want to change the base. That's what it is. Because our calculator don't have a base A, because our calculator only have log or ln. So if you look at calculator, you have log or ln. So you can change it to base 10, or you can change it to base e. So if you want to change to base 10, log ax is the same thing as log x over log a. So the argument goes to the top, the base goes to the bottom. You also can change it to ln x and ln a. Okay, so this is called the natural log, the ln. So this is called a natural log, the ln. And then the base 10 is what we call as a common log. So in the test, sometimes I want you to write this in the natural log, or sometimes I want to write this in the common log. So if you want to write this as a natural log, then you just do ln2 over ln3. If you want a common log, then you do like this case, log 2 over log 3, and then you use your calculator, 0.6309. Okay, so this one is easy. Change of base is a very easy part because the reason why you need to know change of base is because of your calculator. Okay, so for example, we use change of base a lot. Is example will be something like this. Okay. So this question wants you to, like number 6, rewrite this in common log. So common log, if you remember, common log is base 10. So the argument goes on top, the base goes to the bottom. So if you look at question 6, this one is gonna be log 74 over by log 7. So this is how you change. It's very easy. And the question doesn't want you to find it. They just want you to write it down. So you just do log 74 over log 7. So this is called a common log. If they want you to write in a natural log, it's the same thing, but instead of using log base 10, you use ln. Okay, ln 74 divided by ln 7. So this is how you do this case. Okay. Question 7, they want you to evaluate this. So in order for you to evaluate this, you just need to change either base 10 or use the natural log. Okay. So example we have is log 319. So how do you do this is you just do, if you want to do base 10, is log 19 over log 3. Now, if you have a calculator, go ahead and take out your calculator and find out what is log 19 over log 3 and write your answer in 3 decimal places. Okay, so you got log 19 and log 3. Write your answer in 3 decimal places. If you do not want to use log, you can also use ln 19, the natural log, over ln 3. No matter what you do, ln or log, you will still get the same answer. So go ahead and take out your calculator and see what you guys have when you do log 19 or ln, doesn't matter which one you pick, over log 3. Yes, 2. Yep. 680. Yep. Yep, you guys are good. Okay, that is correct. You guys okay so far? I want you guys to do question 9 on your own now. Go ahead and do question 9. Log 2/3 0.135 in 3 decimal place. Log 2, number 9, question 9. This one is easy, and yes, it's coming out in your test. So that's why I want you guys to know the easy one. And still, students still get it wrong. So make sure you got this right. I want you guys to private message me what is answer for question 9 in 3 decimal place. Log 2/3. Harry is wrong. Hannah, make sure you private message me. Josh is correct. Harry is wrong. I didn't ask for present, Josh. I'm asking for question 9. Tina is correct. Huh? I'm not asking for 9. Yep. Elijah is correct. Pasi is wrong. Number 9. Number 9. Matt is wrong. Harry is wrong. Question 9, not question 8. Question 9. Lindsay is correct. Kawena Ware is correct. This is easy. If you're not paying attention, that's why you get it wrong. This is exactly like this question that we just did now. Question 9. Harry is wrong. Matt is wrong. Pasi is wrong. Use your calculator. Not talking about this one. No, question 9. This is question 9. We move on already. Amaka is correct. 3 decimal place. Valentine is correct. So how do we do question 9 in this case is you do yes, Hannah, that's correct. That's how you do it. I'm gonna share it to everyone. So this is how you do question number 9. So you can write in ln form or you can write in log form. So so Hannah did ln. You can also change the ln to log like what we just did here. Your answer is 4.939. Okay. Next, we're gonna talk about a little bit more. Yep, Harry, you got it right. We're gonna talk about the properties of log. So these properties of log is like exponents. If you remember last time when you do exponents, yep, you have the, class, the entire chapter 5, not just 5.3, you need to use calculator. Okay. Remember last time when you guys do exponents, if I have ax time plus ay, what you do with the power when you multiply? Anyone remember? It might have the same base. You guys remember what happens when you do this? When you multiply, what happens to your power? We will have to add them, yes. And what happens when you divide? What do you do with the powers? We will subtract it, right? Yep, you guys are good. So this is what you guys did in exponents. So we do the same thing for log. So when you multiply, you can separate this to become addition. So we call this as expanding. When you divide, we will expand it to become subtract. So that means that one log becomes 2 logs here. And this is a special one. It's called a power. If you have a power up there, if you have a log, you can move the power to the front. This is what we call as expanding. Okay. And then we also have what we call as condensing. Condense it, you make it a single log. So this, you condense it. That means that this goes 2a. If it has plus, you go down to the other side. Okay. Or you have minus, you go to division. If you have an n in front, you can move it to the power. Okay. But be careful with one of these property is you cannot add or you cannot subtract. Means that if you have log ax u plus v, this is not the same thing as log u plus log v. So you don't distribute here, okay? So a lot of students, when they have log u plus v, they distribute to log u and log v. This is wrong, okay? This one is wrong. So do not do this. Don't do that. This is all wrong, okay? So what is log a u plus v? The answer is log a u plus v. So this one has, you cannot do anything on it. Okay, so when you have addition and subtraction, do not distribute, but multiply, divide, you can expand it. Okay, I want you guys to really, really be careful with this one, right? So we're gonna do a bit more of your homework and then we'll continue the rest on Thursday. So for example is question number 10, you have to simplify this one. So how do we do question number 10 here using the properties of log here? You just need to find out log 2 here. So what we do here is this 2 you have to figure out. So 5 squared is 25 times, no, sorry, my bad. This is times, so I can break it down into 2, so I can add them. Multiply means I can add. So become 5 squared plus log 2, 4 to the power of 5. So this is, pay attention, this is very important. So that the multiply, I make it as plus. So what do I do next is this power, I can move up front. So this will become 2 log 2, 5. Plus, now this one is also special. This 5, I can move it up front too. So like we have 5 log 2, 4. Now, unfortunately, 2 and 5, you cannot do anything with it. But 2 and 4, you can do something on it because 4 in this case is 2 power 2. And what happens to log 2, 2? They will cancel out. So what you have in this case is 5 times 2. Okay, so this 4 is 2 to the power of 2, and the log 2 and the log 2 will cancel out. So what happens to this 2 is you multiply with this 5. So your answer in this case is 2 log 25 plus 10. So this is how we do question number 10. How do we do this kind of question? And this very important here. I'll do one more, and then you guys try to do the rest of it, and I will continue some of it on Thursday. Number 12. So you are doing what we call as ln 6 over E9. Now the over, we can write that as subtraction. So you take ln 6 minus ln E9. So this will become subtraction because division becomes subtraction. And ln and e will cancel. They're kind of like, one is exponent, one is log. They cancel each other out. So your answer in this case is just ln 6 over 9. Okay, ln 6 over 9. Let's do 13. Log 525. Now, in order for us to do this, you want to make this the same base. Can someone tell me 25 is 5 to the power of what? Anyone know 25 is 5 to the power of 2? Yep. So what happened is the log 5 will cancel because your bases are the same. You can cancel. So what is your answer here is, your answer here is 2. Okay. So that's why we want to make the base the same, because once the base is the same, you can cancel it. Same thing happens to 14, log 4 to the 164. Can someone tell me this is 4 to the power of what? 64 is 4 to the power of 64 is 4 to the power of, so these are quite fast, actually not too difficult if you know your powers. No, not 4 to the 4. 4 to the 4 is 256. 4 to the 3, yes. 4 times 4 times 4 is 64. But do you guys remember what happens when you put 1 over it? This 3 has to be what? When you put 1 over it, this 3 has to be negative, yes. So that means 1 over 64 is 4 to the negative 3. So what happens to the log 4 and the 4? They will cancel out. So your answer in this case is what? Anyone know what's the answer here? Negative 3, yep. And the last one, I'm doing it, 15, last one. The rest you guys can do it. What we're trying to do here is try to change this to the same base. So log 2, 4th root of 2. Now, we can always write this as 2 to the power of what? Remember, if you have a square root of x, the power is 1/2. If you have a cube root of x, it's power 1/3. So does anyone know what is this power is if I say 1/4? Yes, this is power 1/4. Because 4th root is 1/4. And what happens to the log 2 and the 2? They will cancel out. So your answer in this case is 1/4. Okay, so what you guys do on this is you try to make your base looks the same so that they will cancel each other out. And then the power will be your answer in this case. Okay, I can tell you if you want to do question number 17, your answer is impossible. Why your answer is impossible for 17? Anyone know why the answer is impossible for 17? Anyone remember? Why is impossible for question 17? You do not need to use a calculator to do it. Yes, cannot, no negative, yes. And no negative, so log, you cannot have negative here. How about 0? Log 0. What is log 0? Anyone know log 0 is? I don't care the base. Log 5, log E, log whatever, ln 0. What is log 0? Ln 0 is, again, for zeros, yeah, you're correct, Josh. It's impossible. So make sure you guys understand that if your argument here is negative or 0, it's impossible. If it's a positive, like all these numbers are all positive, I don't care, it's a fraction or whatever you have, you can find it, okay, like what we just did over here. All right, that's it for today. We will finish this. We haven't done finishing yet. So when you come back on Thursday, we will start doing like number 19, number 20. This is quite a lot, but the answer is that this section is actually very easy to do. So we'll do this question on this part of 5.3 on Thursday, and then we do 5.4. Okay, so you got 3 homework due on Monday, which will be 5.2, 5.3, and 5.4. Okay, so that's it for today here. So if you guys have any questions, you can stay back. If you don't have questions, you may go. I'm going to stop